Good morning, everyone. How are you all, guys? A wonderful good morning. All geared up to study? Morning, everyone. That's really nice of you all, guys. So, come on, tell me, how are you all, guys? And how about your studies? Yes, अच्छी चल रही है. That's nice of you. That's really, really nice of you guys. Trust me. Because पढ़ाई अच्छी चलनी चाहिए. Isn't it? Yes, that is, in fact, yes, that is in fact the most required thing for you all guys. कि सबसे अच्छा क्या चलना चाहिए? पढ़ाई. That's very nice. And I hope you all guys are very much geared up to study with me S block element. Is it? Nice. Nihar Ranjan. Hello, beta. Welcome to the class. Nihar, welcome to the class. Good morning, Arpita. Welcome to the class, dear. Really nice of you all, guys. This seeing all you guys so energetic and yes, live gives a lot of energy to me. Really. So, guys, those who could not watch my previous video on S block element, come on, do that because we have been solving NCERT, and not only that, we are doing yes, what we are doing, we are actually revising the whole chapter, completing the whole chapter with all its concept. निहार इज आस्किंग मैम 5:30 से 6:50 के लिए कितना मेहनत जरूरी होगा. बेटा देखो, to be very honest, there is no measuring cylinder or there is no calibrating instrument that will tell you just put in this much of hard work and you'll be getting this much of mark. I'm very honest, very, very honest. But of course, as your target is this, very good morning, Alok. Welcome to the class. But of course, as your target is this, what you should do, I would be telling you that first of all, as long as inorganic chemistry is there, completely do your, NCRT. Ensure your every best that like NCRT is totally done, guys. I'm repeating, NCRT should not be missed at all. Try to ensure that you complete your NCRT thoroughly. I'm really repeating it again. It is very, very must as long as inorganic chemistry is concerned, guys. Mola, good morning, beta. Pooja, Khare, remember me? Yes, I do remember you, Anya. Very much, I do remember you. And just, you all guys giving me a lot of energy. Trust me, I am just, get energized looking at your messages and everything. So, Nihar, ma'am, I worked so hard this year, still score just 530. So, I start doubting myself. No, beta. Never doubt yourself. You are extremely good. Extremely good. And I would be rather saying that think about all those who got less than 530. There were many, there were many of the students who must have got less than 530. So at least you are better than them. And trust me, only the score is not going to, judge all about you. I'm repeating, only the score is not going to judge about you. And you should also not do that. I'm repeating, you should also not do that. There are many criteria. You might be good at so many other things, but of course, you have to be equally good in studies also. There's no point in giving a second chance. No problem. I have seen many of them. You have done extremely well, Nihar, but I have seen many of them who could not do even this in their very first attempt, but in their very second one, they have just rocked. Seriously, trust me. They have just rocked. There are so many videos kept on YouTube also. If you don't trust me, you can watch all of them. And if you really don't trust them, just give a personal messages to them and just try to have a call to them. Really, it happens. So, Nihar, I would really tell you that first of all, beta, first of all, no one is better than you. Think that because it is only who is going to be there wholeheartedly, all 100% with you. And yes, it is only you who is going to work for yourself. So first of all, Nihar, am I clear, beta? Don't doubt yourself. You have done extremely well. Trust me, you have done extremely well, dear. Mola, good morning, beta. So, Nihar, if I'm clear, come on, give this one. Pakka, you are not going to doubt yourself. Come on, promise me here only. Don't doubt yourself. You are extremely well done, guys. And remember, Nihar, this very next attempt, you are going to rock like anything. Trust me. You are going to, and together we'll rock, beta. Together we are going to rock. Don't worry. Nihar, yes, ma'am. Thank you for the support. Always there, beta. Always there. So, once again, guys, a wonderful good morning to all of you. Snehang, hi, beta. How are you? Nihar, I will take a drop. That you should, because this your score is telling that you can do extremely well. If in the very first attempt, giving all those bored, facing all the scenario which we are around, like COVID is going on, so many social disturbances there around you. In spite of all that, if you have scored 530, that means lot of you just have a lot of potential in yourself. Trust me. So there is no scope of doubting yourself. First thing. And secondly, beta, see, this time COVID was there. You had to go out to give the exam, and so many hurdles were also there. In spite of all that things, isn't it? You could get this. That means you could have done extremely well. That is your potential. So realize your potential, Nihar, and trust me, you are going to rock. Trust me, I'm repeating again, you are going to rock this time. Snehang, should I take a drop? Okay, Mola is saying thank you, ma'am, for encouraging us. Always there for you all, guys. Don't worry. I'm scoring 580. Okay. It all depends whether which college you are looking for. Snehang, you are saying that you want to score, you are getting like a score like 580. It's very good score. It's really a good one. But yes, it all again depends on the college you are like looking for to get into. And I would always suggest you to go for a good college. I'm repeating, you should always go for a good college where you'll be having a proper amenities so that you can pursue your MBBS in a much smarter way. And what is the meaning of smarter way? Because see, here you will have to practice. You agree? You will have to studies. Lot of studies will be there. A lot of practicing will be there. So the college, you should look for the college which is very good. Okay, in terms of amenities and every infrastructure. That way you should you look for the college. Okay, and then you should decide whether you should go for a drop or not. Then Snehang, you should not. Then I would say, then okay, ma'am, any college in West Bengal, ठीक है. See, already you have taken a 2 year drop. There is no point in taking drop further, because see, all this MBBS almost take 5 years. Then interns you'll be doing, and truly speaking, people are going to trust doctors only when they are having some practice experience. I hope you just didn't feel bad about it, but this is actually the reality. This is actually the reality. Whenever it comes to doctors, we only go to those doctors who have done so many practices, who have been doing practices for so long, isn't it? That is a very bitter fact of it, but yes, we have to accept it. Okay, then yes, you are 19 years now. Then you should, I think for it. Purnima Patel, ma'am, should I take a drop of NEET 2021 because now I'm in class 12? It's too early to think. I would say because you are in class 12, it's too early to think for a drop. Give all your heart into studies and just try to make this every 2021 into, yes, into a wonderful rank. Okay, because we have a lot of time now. This is not less. बहुत होते हैं. If you all study with all your heart together, with all your hard work together, a strategized hard work, trust me, you need to have a strategized hard work. ऐसा नहीं कि बस कोई भी topic उठाया and just randomly just go on studying. No, just try to have a strategized hard work. That is surely going to ensure your very success in this NEET 2021. And I would be saying, like, you are in class 12 now, so it's too early to decide whether to go for a drop next year or not. Because this year also, like, if you have decided from now onwards and if you will put all your hard works together, you're definitely going to crack this year only. Not a big deal. Okay. Nihar, ma'am, आज से आज एस ब्लॉक रॉक करेंगे बिल्कुल. बट आई जस्ट वांट टू टेल यू निहार, दिस इज द वेरी थर्ड consecutive third lecture on S block. Two lectures have already been uploaded on YouTube. So do one thing, the link for the same lectures is there in the description box. After this class you must watch them. Okay, so I hope I am able to clear all your doubts. Yes, if it is there, give this in the chat box faster. Okay, thank you, beta. Mola is asking, ma'am, how to by heart D and F block element. Ma'am, I feel very different to by heart it. Mola, let me tell you one thing. There is nothing like you have to mug up things. Okay, those who have seen my P block, I mean periodic table, they personally messaged me and told that, ma'am, we found that lecture very, very wonderful, very, very interesting. And as I've given so many, tricks like octopus trick is a never before trick. I'm repeating, I have given octopus trick, which is just a never before trick. And that is going to solve all the questions in compare whenever it comes out to compare electron enthalpy of any element out periodic table. So just follow that. And that is not only one, there are so many tricks under periodic table I have given in my video. And yes, in S block also I have given so many tricks. And see, there are a lot of confusion when it comes to reasoning questions, whether you talk about solubility, stability, thermal stability, or which one is going to form precipitate and all. Everything you are going to find in all my video. So don't worry for D and F block as well, because this boron carbon is almost done, S block is almost done. Very soon I'm going to bring video on nitrogen and phosphorus, and that is of course, I mean, nitrogen family and oxygen family, followed by halogen. And after that, very soon you will be having video on D block or by just D and F block elements. And yes, you are going to realize that there's nothing to buy hearted. Simply, you need to watch the video with all your eyes on the screen. Okay. And yes, with all your heart in the topic. Then you need not to mug up anything. You will simply, the moment you will keep on watching my video, the moment you will keep on learning everything. Okay, guys. If you don't trust me, don't trust me. I would be telling you, don't trust my words. Just, just check my words. Going to the link of my video, watch it yourself, realize it yourself, and do give comment over that. Because yes, your comments are always more welcome, and that is going to motivate me in order to make things very, very easy for you all, guys. Okay. So I hope there is no query now. Now let us start. Or if there is any other query, please keep putting that in the chat box. And now let's start, isn't it? So welcome you all, guys. Once again, a wonderful morning to you all, and hope you all have a wonderful day ahead. This is Sharada Alok, and I have been teaching chemistry at Resonance, which is a renowned coaching institute of Kota from past 10 years. I mean, it is not only the renowned coaching institute of Kota, rather renowned coaching institute of India. So I've taught there from past 10 years, guys. Now, there must be a question in your mind like how to get connected to us. Let me tell you that straight away. You have to go to Play Store. Just download the Unacademy learning app. I'm repeating. You have to download Unacademy learning app, because many of the students are telling me, ma'am, there are two apps. One is an academy learning app, and the other one is educator app, an academy educator app. Hello, Alok, how are you, beta? How are your studies? All well? If it is all well, guys, sitting out you there, come on, give this in the chat box. And one more thing, if you all are watching, do one thing. Take a pause, take a break for 1 second, and share this video. Just share this video to all your friends so that they also can join it. Secondly, if you are new to the channel, subscribe it. And all those who are watching it but have not subscribed the channel should also subscribe it. And yes, don't forget to press the bell icon in order to have all further notification, so that you just keep getting the quality educations without a break. Okay, very good, Alok. All is well. That's very good. Everyone should have all is well. We should have a kind of all is well feeling, because life cannot be smooth. And if it is smooth, it is not at all going to be enjoyable. Trust me. So it should have some, up and down like ECG goes on. It should have. Because if ECG, that is actually the life that talks about your life, is also having these type of curve, isn't it? So our life should also have, but all of the top, we should always feel what, all is well, isn't it? So let's start the here. So, guys, there should not be any confusion. We are having an Academy learning app straight away for students and an Academy educator app that is for, of course, the educators, for us. So, what you have to do, you have to go to the Play Store, download an Academy learning app. So after that, you have to just click on to NEET UG option and then go to subscription. Click on subscription part in order to take the subscription. Okay, we'll be talking about that just after a few seconds. But first of all, let me tell you the benefit of taking plus subscription. So guys, you can see on your screen that you get daily live classes. What does that mean? You'll be taught, I mean repeating, you'll be taught by the top educators in these daily live classes. Not only that, you can ask all your doubts, and yes, that is going to be cleared there itself by those top educators. This is going to enhance your very preparation for the particular topic, and of course going to add a lot of confidence as well. Apart from this, we do have polls. What is that? Here you'll be asked particular question based on the topic being taught by the educator, and yes, you are supposed to give answer. There might be option like different, believing in that. And apart from that, here you'll be getting a bi-weekly reviews. Not only that, these bi-weekly reviews will not only improve yourself, not only give you a prospection into yourself, but of course they are going to highlight your progress as well. So needless to say, just take once iconic subscription and get this, all of these, and yes, this one as well, guys. Now, by this time, there must be a doubt whether to go for plus subscription or to go for iconic subscription. Let me make you very clear now. See, whatever you are supposed to get under plus subscription, you are going to get under iconic as well. But yes, these are the additional, these are the additional features you'll be getting in addition to that. What you have been getting under plus subscription by taking iconic subscription, guys. Now, how much you have to pay? This should be the question in your mind. If it is not there, this should be. So, for 1 year subscription, you have to pay 45,000. I'm repeating, for 1 year subscription, you have to pay 45,000. That cost you around 3,750 rupees only. And if you are planning to go for 2 year subscription, you are supposed to pay 61,000. That cost you around 2,542. More the duration, less the cost of subscription, isn't it? Yes, it is. So, guys, once again, I just want to tell you that whenever you are planning to take the subscription, do refer this referral code of mine, which is really very easy to remember, very, very simple. It is SA10. I'm repeating. It is very simple to remember. That is simply SA10, guys. Now, guys, if you don't want to go for iconic subscription and planning to go for plus subscription, let me tell you the cost for that. Here, right from 1 month to 2 years subscription option are right up on your screen. But let me tell you that if you're planning to go either for 1, 3, or 6 month now, that is useless. You can think definitely if you want to think them for them, you can think, but try to think when it comes to like you're just either 1 month away or 3 month away or 6 month away from the exam. Presently we are almost 10 month to hai that we can sure of, we can pray, we should in fact pray. Okay, as this time it happened, this should not happen like that. We can pray, but that is also not in our hand. But at least I can say that at least 10 month to hai, usse zyada sakta hai, not less than that. That is for sure, that I'm very much sure of. So guys, let me take you here. So just if you want to take this 1 year subscription, you are supposed to pay 27,000. That cost you only 2,250 rupees per month. I'm repeating. If you if you are planning to take 1 year subscription, just pay 2,250 rupees per month and get the subscription. And yes, those who are in class 11 planning to go for 2 year subscription, you have to pay 32,400. That cost you even lesser, only 1,350 rupees per month, guys. So I would like to tell you once again that if you are planning to take this subscription, come on, apply this referral code of mine, which is really very easy to remember, guys. SA10. I'm repeating. It's very easy to remember. SA10. Welcome, dear. So how are you all guys doing? So all geared up to study? That's really nice of you. Good morning, Pankhudi. Shiraz, welcome to the class. So all you guys, come on, get gear up to study with all your pen and copy in your hand, all your eyes on the screen, and yes, most importantly, ensure that wherever you are sitting, you are not surrounded by anybody who is going to disturb you. Yeah, two of you student can sit together, no problem, but just ensure your every moment that you are not disturbed by anybody while we are together, okay, via the screen. So guys, let me tell you, today I'll be taking S block element part 3. Yes, we'll be covering, of course, we'll be covering this NCERT solution question wise, but remember, as I have done in my two previous video on S block, I try to complete all the chapter, I try to give you all the tricks, I try to explain you in a very easy way. So just after looking the video, trust me, just after looking the video, you'll able to do all NCERT question, NEET question, and J mains question based on this. And of course, for advance also, it is going to help you guys. So this is really extremely helpful, not only to NEET UG student, but for all you guys who are preparing S block, or all those guys who just want to master their S block. You should watch this video of mine, and link for my previous video on S block is given there in the description box, guys. So I hope you all guys are going to rock this moment as well. So I once again welcome you all to our very own channel, Let's Crack NEET UG in English. And let me tell you, before we start, let me tell you about our Ignite batch, guys. This Ignite batch, where all four faculties, Vipin sir is taking your zoology at 11, myself taking your chemistry at 2. We come live daily at this particular time. Aditi ma'am is teaching botany at 5. Rahul sir is teaching physics at 9, guys. So we all come live daily on YouTube. Also, you can prepare yourself here, or you can join to plus subscription. But rather, I would be telling you, go for iconic subscription or plus subscription in order to have a regular preparation. In order to have a regular preparation, guys, you must join there. Okay. So I hope you all guys got it very clear. Now, without delaying, let us start. Let us start the chapter. But let me take a quick revision, which I have already given you a lot minute trick for this. But let me take a quick revision as well. See the flame color. You know that this S block element are characterized or are identified by a very specific test for them, and that is flame color. Their chloride, when heated to flame, yes, their chloride when heated to flame, they just give a specific color, and that is how they are identified. So let me give you the trick for that. Yes, lithium is giving you red. Basically it is called as crimson red. So kaise, how to remember this? La se lithium, la se lal. Now sodium, can you see this is pila sunehra, yellow, sa se sodium, sa se sunehra. Now potassium is purple. Potassium is lilac. Here it is written lilac. Purple, lilac, violet are all same. They are different shades. तो यहाँ पे कौन सा ड्रेस पहनना है अपने को? Why to be so specific in color? Lilac, purple are of like, there is a very slight difference. That way you can learn it. B for potassium, P for purple, purple for lilac. Okay. Now magnesium. Magnesium gives no color. See guys, beryllium and magnesium of alkaline earth metal gives no color because they have very high ionization energy. So they are bugger machine. Buggers चिपक के रहते हैं. कहाँ? Their electrons stuck, quite stuck to the shell. It's not ready to come out by the flame because the ionization energy, the forced ionization energy required for so is not provided by the flame. आप इसको ऐसे भी याद रख सकते हो. बड़े मठ. Mat is a kind of a word which means, it is a Hindi word that means deed. तो बड़े ढीठ है ये लोग, बड़े मठ है. Their electron is not going to get excited by the flame because the flame is not able to provide ionization energy required for them. Okay. Whereas all other elements, the ionization energy is quite provided by the flame. Now the calcium. can guys look at this. Calcium basically is known to give brick red color. C for calcium, C for cabin. A cabin is made by the brick, so brick for brick red. Now strontium is simili. Simili. Simili means what? Simili, that is similar to lithium. You had just seen that lithium gives lithium, lithium. Lithium gives crimson red color. So strontium also gives similar to that red color. Then coming to this barium. Barium is what? B for bada, A for apple, that bada apple, mehenga apple. Mehenga apple is Smith apple, that green apple. So apple green is the color, or grassy green also you can call it. The color is not exactly matching, but here is this, in this case it is matching properly to the color, guys. So that was just a quick revision, but I've already covered it in my previous video. Now let us start, guys. So till 10.6, I'm repeating, till 10.6, guys, we have already done 10.16 we have already done in my previous video, and you can watch it there going to the link given in description box. And yes guys, now we are going to start with the very next question of S block, but before that I would be asking you to share it. Come on guys, if you have not shared it so far, do that so that all your friends can be the part of this. And those who have not subscribed the channel, even in spite of watching it many times, do that. Secondly, those who are new to the channel should also subscribe. I hope this is all clearly going here. You must have liked the video. Do that, guys. Don't delay it any longer. That's really nice of you all, guys. So shall we start, guys? Come on, let us start. Can you read the question on the screen? What happens when? Welcome, Ashulaja. Welcome, beta. Welcome, a warm welcome to the class. A wonderful morning. So, all your eyes on the screen, copy and pen, and yes, ensure no one is then. Yeah, look at the screen now, guys. What happens when magnesium is burnt in air? See, magnesium, or if you talk about any alkaline earth metal, when we heat them in air, they not only react with O2, rather they also react with N2, guys, and form their oxide, here form their nitride as well. And this together looks like, wood ash. Therefore, this mixture is also called as wood ash. I'm repeating, this mixture is also called as wood ash. And there have been many questions based on this, that on the behavior of this wood ash. So let me cover that as well. On dissolution in water, guys, this is going to form an alkaline solution of magnesium hydroxide, which is yes going to change the color of lead litmus to blue, and secondly its pH is going to be basic, alkaline it is. Okay, now it will give away one of the gas, which is alkaline gas. Remember guys, ammonia is an alkaline gas, whereas all other gases are either neutral or acidic. I hope it is clear. So this is the general characteristics of alkaline earth metal, guys. Whenever they are made to react with air, they do react with oxygen as well as nitrogen. Okay, but ensure that if you take beryllium and magnesium, I'm repeating, if you take beryllium and magnesium, ensure that the surface should be scratched properly so that the surface should have magnesium atom. Okay, not the oxide of it. Or if you are taking beryllium, ensure that it is in amorphous form, because these two have a very hard layer of their respective oxide, which does not let them react easily with air even after strong heating. So ensure that either beryllium is there in the amorphous form or magnesium is well scratched over its surface. I hope that is clear. And one of the very interesting feature of this is, you know what? Yes, let me tell you, the most interesting feature here is, guys, this lithium. I'm repeating, this lithium, Lanka Bhedi. is the only, yes, it is the only alkali metal which also reacts with oxygen and nitrogen like them. None of the other alkali metal is going to react this way. Okay, so you can see why I have called it as La Silanka Bhedi, La Lithium, because it does not show much similarity. It does not show similarity with that of alkali metal, though it stays with them, though it is placed amongst them. It shows all its most of its similarity to that of alkaline earth metal. तो रहता कहीं है और किसी और का similarity दिखा रहा है. That is the reason it is called as Lanka Bhedi. I hope it is going to be memorable, guys. So all our eyes on the screen. Welcome, beta. Welcome to the class. Now look at this. Quicklime is heated with the silica. So let me tell you the formula of quicklime, guys. It is calcium oxide. Okay. Now how do we represent silica? SiO2. Yes. This is a basic oxide. Basic oxide. This one is an acidic oxide. You guys know that when bases reacts with acid, what forms? Salt. So here also what will happen? When you will heat it, this will form calcium silicate, CaSiO3. It is what? Calcium silicate, guys. So this is a salt, acid, base, and acid together forms the salt like this. Now the next one is chlorine reacts with slaked lime. Chlorine is this. Slaked lime is what, guys? Calcium hydroxide, also called as lime water. Okay, why it is called as slaked lime? Because on addition to water into CaO, this slaking is called as slaking of lime, the formation. Therefore, the one which is coming out of it is called as slaked lime. Okay, it is clear, I hope now. And together this form actually CaCl2 and also, guys, CaOCl and Cl, which is actually, yes, calcium oxychloride, and yes, water will also be forming here. So guys, this mixture is actually called as, yes, this particular one is called as bleaching powder. We call it as bleaching powder, and yes, we do use it to kill germs, especially in washrooms, because this comes very at a very low cost. So washroom, or you can say at such places, in order to avoid the growth of moth and all, because they are going to produce what? Nascent oxygen. And this nascent oxygen, this nascent oxygen that is represented by this Cl in an square bracket, that is actually going to kill the germs over there. Okay, is this clear, guys? Now you can see that there are two acidic radical. Let me change the pen here first. There's this calcium, what type of salt it is? On the basis of presence of two acidic radical, you can see one is hypochlorite, the other one is chloride, and this one basic radical, this is what? A mixed kind of salt. Mixed salt. Such a salt which consists of either two basic radical or more than that, or two acidic radical or more than that, are actually called as mixed salt, guys. Now coming to the last one under this is calcium. What happens when calcium nitrate is heated, guys? This is how calcium nitrate is represented. Okay, is this clear? Calcium nitrate. When we heat this, first of all, we get calcium oxide, guys. We get a reddish brown color gas, and that is, yes, NO2. This is reddish brown in color due to one unpaired electron over it. And then we get, guys, oxygen, which is a colorless life-saving gas. Why I'm giving you these terminologies? Because these questions are not asked this way. Okay, as long as school exam are concerned, these questions are like asked like this. Okay, but even now in school also there are certain paragraphs where you have to be very specific. In board, paragraphs are made, in NEET, paragraphs are made, and then you are supposed to answer like a compound A is giving a reddish brown gas, B or a life-saving gas, C, identify the compound. That way the question will be asked. So you should know every much about the product being formed or the reactant used. Okay, so NO2, why it is reddish brown in color? Because of the unpaired electron. And this is a life saving. So there are two gases, yes, appearing over here on heating calcium nitrate, guys. I hope this is clear. If it is clear, come on, guys, give this. Salim, welcome, beta. Welcome to the class. It's really excited. I'm really excited to see all you guys studying like this. But yes, yes, that is very nice. You have not still shared to your friends. Do that. फटाफट से share to all your friends and ask them, आ जाओ S block की पढ़ाई हो रही है. Ask them to join it. And trust me, it is not only going to help to your need, but it will help you to prepare S block thoroughly. So all those guys who just want to prepare S block, come and watch this video of mine. And trust me, none of the question will be unattempted by you based on S block. So spread it to all your friends. Ask them to come and join the video. And yes, if you have not liked it, do that. And all those who have not subscribed the channel, do that, beta. Do subscribe. Let's crack NEET UG in English channel. And yes, press the bell icon as well in order to have further notification. So guys, do you find the next question on the screen? Describe two important uses of the following. The first one is caustic soda. Yes, caustic soda is very easy. Caustic soda, sodium hydroxide is called as caustic soda, and we have already seen how it is prepared from Kastner-Kellner cell. Okay, guys. Now, what are the uses of this? Let me tell you. First, this is used for refining of petroleum. It takes away the grease out there. It takes away the grease out there, guys. Okay, because it reacts with those oily substance, convert it into uh, soluble soap kind of substance, which gets removed easily. Apart from that, it adds, lot of, what should I say? Yes, this is added to cotton fabric. Cotton fabric, what it does there, yes, it gives lot of strength. It gives lot of strength. Okay, which is going to add, and yes, lot of strength to the fabric, and of course going to add luster. All those guys who must have studied in class 8, do you remember? You must have studied in class 8 under the formation of rayon, where the wood pulp, I'm repeating, where the wood pulp is, याद आ जाएगा सबको, अभी तुरंत से याद आ जाएगा. Wood pulp was treated or is treated with sodium hydroxide. That gives you alkali cellulose. And yes, this is further added with CS2 and then further added with H2SO4. And ultimately, what do you get? Rayon fiber, which is also called as artificial silk because the luster it has. And yes, all these reagents are going to add strength to the fiber. Because guys, all these cotton fiber and all natural fibers are not that, they are not that stronger, that strengthier. Aromal Vipillai. Aromal V. Pillai. Welcome to the class, beta. So nice to see you. Sabarish. Okay. Okay, Sabarish. Welcome to the class, beta. So guys, all your eyes on the screen. So the use of NaOH is clear to you or not? Yes, it is clear. Come on, give this one. And this whole process where it is going to add strength or luster is collectively called as mercerizing. I'm repeating. This process is called as mercerizing. Mercerizing. This might not have been told to you guys the step. Mercerizing is actually a method in which lot of strength is added, luster is added to the fabric. This process is called as mercerizing. Remember it, because I promised you in the very beginning that I'll be teaching you so many things which might not have been asked so far, but yes, chances are there to be asked. So yes, this is one more addition to that. Mercerizing is adding a lot of strength to fabric, at the same time adding luster to the fabric. And yes, it is very well done by sodium hydroxide, guys. I hope it is clear. You all guys are enjoying. Come on, come on, come on. If you are doing so, share it to all your friends without any delay. And yes, this is of course bauxite. Bauxite is what, guys? I've done this under boron carbon family. Is a very famous ore of aluminium. Yes, enrichment of bauxite is done by NaOH. And the very famous process named so is Bayer's process. So I hope it is clear, guys. If it is clear, give it this one faster. Good. Now we are going to go with sodium carbonate. Welcome, dear. Welcome to the class. Important uses of sodium carbonate. Let me tell you, no doubt it is used. First of all, the first use is water softening. Yes, water softening. Clear. Then laundering also it is used. Clear. Cleaning purpose also used, guys. Okay. And yes, at the same time, very importantly, this is used to manufacture glass, soap, borax. Okay, all these are clear to you guys? Pakka. Paper mein, paint mein, textile industries mein, there are many places where the sodium carbonate is used, guys. Okay, फिर से repeat करते हैं. Glass, soap, कुछ भी, any 2 3 example will work. Soap, glass, borax, water softening. Okay, that's clear, guys. Now the next one is quicklime. You know what is quicklime? Let me tell you, there is a lot of confusion. This is limestone, guys. This is limestone. Then on heating this, it gives CaO, which is called as quicklime. When CaO is added to water, it forms, yes, lime water or slaked lime. Is this clear? Is this clear to you all? So they are asking for this quicklime is for CaO, guys. Just a sec. Let us look back on the screen. CaO. Okay, that's nice of you, beta. Thank you so much for that. Now, all your eyes on the screen, guys. The CaO, which is called as quicklime. Yes, this is actually used to manufacture what you know. This is used to manufacture sodium carbonate. This is used to manufacture sodium carbonate. Welcome to the class, beta. So really very happy to see you here. बहुत अच्छा लगता है when you guys are there. So that's really nice. Very good, beta. Very nice of you. Thank you. Now it is also employed in purification of sugar, guys. Dye stuff and sugar also. Okay. Is this clear, guys? Is this clear? Sure. चलो आगे बढ़ते हैं. Now, very importantly asked question. In fact, it is not only the part of this topic, but also many times you have been seen that it can be asked under chemical bonding also. BeCl2 in vapor and BeCl2 in solid. So first of all your eyes on the screen. Let's see BeCl2. This, you all know that beryllium is 1s2 2s2, guys. So this is beryllium. Okay, now Cl here, there is nothing here but two sigma bond. So steric number is 2, guys. So hybridization is sp. Is this clear? So geometry is linear. BCl2 is what? Linear. I hope there is no problem to that. And yes, you guys, you can see this sp hybridization is possible by 1s and 1 p orbital. Still two p orbitals are there which are empty. One is this way, the other one is this way. Is this clear? Yes, is it clear to you all guys? Because this is very important to understand here. That is why you will, that is after that only you will able to understand this first of all. So there are two empty orbital present on beryllium. That is clear. So what happened guys in vapor state? I'm repeating, in vapor state. Let me draw this here. What happens? This beryllium, okay, and the chlorine in vapor state, what happens? This gets bent a bit. And why it happens to show guys? Let me tell you. There was an empty orbital here. And yes guys, a filled orbital with lone pair on chlorine. So what happened? The empty orbital present on beryllium and the lone pair present on chlorine just overlap and form a back bonding like this. I'm repeating, that forms a back bonding like this. Okay. But remember, still one orbital is empty here. And same happened with this also. Okay. And yes, this is what guys? This is a chlorine bridged dimer. What do we call this? Chlorine bridged dimer. And yes, in vapor state, if you are asked to draw the structure of BeCl2, this is the structure on the screen, guys. There should not be any confusion. And always remember the back bonding forms between an empty orbital and an orbital which is filled, or in other words, straight away say lone pair. Is this clear to you? Is it clear? So now what is here? The hybridization is sp. In this case, there are steric numbers 3. So the hybridization is, yes, what is the hybridization? sp2. Hope it is very well cleared. Pakka say, pakka, if it is clear, that's good. Many of you are saying that yes ma'am, samajh mein aa gaya. Nice. Yes, come on guys, if you have not liked it, call all your friends, फटाफट से सबको बुला लो. Call all of them, ask them that yes, S block is being taught on the screen live by Sharada ma'am. Come on, join it. So all your eyes on the screen now. What about BeCl2 in solid state? See guys, in solid state they come further closer to each other. They've come further closer to each other because still, just now you had seen that still, I'm repeating, there is still one empty orbital left over here. One empty orbital is there, which is still one, even in even after getting into the back bonding, one empty orbital is still present on beryllium. So what happened guys? These BeCl2 unit in solid state, they further come closer and further there is a back bonding between another lone pair, between the lone pair of chlorine and the empty orbital present on beryllium guys. So because of that, you know what happened? It looks like this. This is very important guys. See, this is the wedges. You guys all know the meaning of wedges, that they are not in the plane of the screen, isn't it? Yes. Okay guys, and the BeCl2 get further this way. So the angle which was 180 between them, I'm repeating, the angle which was 180 between them, now the angle is somewhat 98. Here the angle is 98 degree guys. Okay. Now what happens? Again there is a back bonding like this. Okay. And yes, this goes on and we get a polymeric, yes, what do we call? A polymeric structure of BeCl2 like this guys. Is this clear? So these wedges means these bonds are not in the plane. Is this clear? Is this clear to you all guys? पक्का सबको आ रहा है समझ में? Nice. So this is how, and it is very well clear the hybridization here, because the steric number is 4, the hybridization is sp3. So on every beryllium there are two back bonding from the Cl of the adjacent one, and it is possible because there were two empty orbital present on beryllium. Sure. Okay, is this clear? If it is clear, come on, give this one, guys. So this is basically called, this particular one, this is polymeric structure, guys. Very, very important, guys, has been asked many a times. So all your eyes on the screen. This is called, this is what polymeric structure, and these are the chlorine bridges, guys. Polymeric structure with Cl bridges. Most of the time, this is a fact kind of question. What is fact? Frequently asked question. Whether you talk about your board exam as per NCERT, or you talk about NEET, this is a frequently asked question. So बहुत ध्यान से देखो. I'll repeat it once again for you guys. So beryllium chloride, in vapor, it exists as a dimer, and in solid, the molecules, this BCl2 unit comes further closer and get arranged in this polymeric structure with Cl bridges. So in both the cases, Cl bridges are there, guys. But see, here the hybridization was sp, here it is sp2, and here it is sp3. So these type of question, there are so many questions on the basis of this, that what is the shape, or what is back bonding here, or whether do exist in polymer or dimer in vapor phase, or polymer or dimer in solid phase. Such type of question is frequently asked under this. As if you have not liked it, come on, like it. If you have not shared it, do that. Done? Hope you must have done it. कुछ लोगों ने नहीं किया है. Come on, do it. So guys, look at the screen. The hydroxide and carbonate, I'm repeating, the hydroxide and carbonate of sodium and potassium are easily soluble in water, while the corresponding salts of magnesium and calcium are sparingly soluble. Let us see this. Sodium and potassium are alkali metal, guys, remember. Whereas magnesium and calcium are alkaline earth metal. All of them belong to S block. Welcome, beta. Ahuti, welcome to the class. Now, all our eyes on the screen, guys. Alkali metal and alkaline earth metal are these. Okay. Now, it is said that carbonates of sodium and potassium are easily soluble. These are soluble. These are soluble. Whereas these are sparingly soluble. Why it is so? Let me tell you. See, guys, whatever property, whether you talk about solubility for alkali metal, let us see. For alkali metal, we compare the property majorly taking their electropositivity. They're most electropositive in every period. Done. And yes, you can say except lithium, but remember Lanka Bhedi. Okay, so except lithium, all of them are extremely electropositive. Very readily they lose their electrons. Done. So what happens in this case? We compare whether you talk about their solubility, whether you talk about thermal stability, everything with respect to electropositivity. And that is the reason, guys, if they are electropositive, their carbonate is very much ionic. Their, their carbonate, or if you talk about hydroxide, hydroxide is extremely basic and carbonate is extremely ionic. And that is the reason, you all know that, like dissolved like ionic compound, polar, very, very go for polar solvent. And that is the reason whether you talk about hydroxide of alkali metal or carbonate of alkali metal, that is much soluble, guys. Remember, I'm repeating, if you are asked to compare Properties of alkali metal compound. Just take electropositivity at the basis. Whether you are asked to compare hydroxides or you are asked to compare solubility of carbonates or sulfates, anything, they are soluble because of this. Okay, guys, because of this. Is this clear? Done? Now, guys, look at this. If you talk about if you talk about alkaline earth metal, scenario is bit different. Let us see how. See, as long as hydroxide are concerned, that is, you have to compare the basic nature, no doubt. Basic nature is going to be compared with respect to electropositivity, guys. Remember, whether you talk about basic nature or you talk about thermal stability, I am repeating, whether you talk about basic nature or thermal stability, it is to be compared with respect to electropositivity. Done. And you guys know that as you move across a period, they are less electropositive than alkali metal. As they are less electropositive than alkali metal, so they are less basic than alkali metal. And if it is less basic, it has to be less soluble, guys. Is this clear? Less soluble means what? In other word, sparingly soluble. Sparingly soluble means what? Less soluble. Done. Now look at the solubility for carbonates, guys. If you talk about carbonates, if you talk about sulfates, if you talk about, okay, carbonates, sulfates, if you talk about all this, you know what happens, guys? These these are to be compared with respect to size. And if we take size, that means we have to compare lattice energy. Done. And you guys all know that if lattice energy is overcome by hydration energy, then only it is going to dissolve. Sure. Done. So what happens in case of calcium and all? These carbonate are bigger in size, guys. Carbonates are bigger in size. Remember, carbonates are bigger, guys. These are bigger. Guys, all your eyes on the screen. I'm going to tell you something which is actually very, very confusing. First thing, if you will try to complete them just by reading the notes, are never going to help you. And yes, why it is not going to help you? Because ultimately we are studying for clicking the correct option in MCQ or answering in subjective way. That you will able to do only when this particular thing is clear to you without any confusion. Just by reading the book, these are not going to clear. So confusion will remain there. Negative marking will also be there. So come on, guys, all your eyes on the screen. Quietly watch it. Try to grab it. If you have not liked it, like it. Not share it, share it. Not press the bell icon. Do that. Okay. Now all your eyes on the screen. So guys, carbonate ion is bigger in size. Whereas with the comparison of this, magnesium and calcium are what? Yes, magnesium and calcium are what, guys? That is also comparable, you can say. So what happens because of that? Always remember, a bigger anion stabilizes bigger cation, and smaller anion stabilizes smaller anion cation. Big anion stabilize big cation, small anion stabilize small anion cation. So you can see that less the size difference between cation and anion, better is the packing. दोनों बड़े बड़े, if big cation and big anion are there, there the crystal packing will be very proper. Or if both of them are smaller, again the crystal packing will be very proper. In that case, lattice energy is going to be high. And if lattice energy is going to be high or overcome by hydration energy, solubility will be less, or you can say it is sparingly soluble. Done. So both of them are bigger, so difference in size is less. So better is the crystal packing. So higher the lattice energy, or you can say lattice energy is overcome by the hydration energy, and therefore it is sparingly soluble. Done. Is if it is done, then give this yes, and yes, come on, have a last look at the screen because I'm going to switch on the next screen, guys. Now the next question on the screen is importance of limestone, cement, plaster of Paris. Just now we have covered what are the importance of limestone, guys. Plaster of Paris and cement. Let's just cover them here. What is cement, guys? Come on, tell me what is cement. Is it running? What is cement? Tell me faster. What is cement, guys? Yes. And yes, if you have not shared it, share it to your friends. Yes, cement से building बनती है. Correct. Cement is the major things required for construction, constructing buildings and all. घर भी बनता है, छोटा बड़ा सब. Yeah. Let me tell you about cement, guys. You must not have studied it this way. Trust me. These topics seem to be like we always look whenever we study as block we look for properties or ये compound के बारे में थोड़ा बहुत पढ़ा like for cement or what we study कि gypsum is added to slow down the settling to decrease the settling time in order to make it more harder. That much only we study about cement, and we just take it like this. We take these things so lightly. I am repeating, we have been studying in a way that there are so many things like this on the screen we take very lightly. I'm repeating, we take very lightly. And when such things are asked in exam, we cannot do them correctly, or we make a negative attempt by mere just by mere you know kind of thing, simply overthinking over that. Dadaji ka 1, 2, 3, 4, tukka, yes, 2, done. And that is wrong. That gives you a negative marking. And when you come out of the examination hall and you tell all your parents, all your friends, I though studied a lot. Beta, listen to my words. They might act as a turning point. Okay? So listen to me. What happens? These things you just go through like this. Most of you even do not give attention to them. And just by putting tukka and all at the time of exam, when you come out or when the result comes out, there is a negative attempt you already had done. That the very moment you come to know as soon as you come out of the examination hall, because the very next moment you check it whether you have done it correctly or not. And then what do you complain to all your friends and parents and to yourself? I studied so hard. I studied so hard, but I'm not getting this much mark. It happens, guys. Let me tell you why does that happen. Because there are many topics. Of course, there are many topics which needs lot of hard work. But at the time of exam, and you must have studied also those topic, okay? And you feel that, see, there are, suppose in chemistry there are 32 chapters. If you talk about NEET, basically majorly 32 chapters are there. Okay. So there are many chapters which you simply keep on ignoring, whether you talk about most of the inorganic chapter, because in inorganic, what is the general tendency of student, chemical bonding kar liya, ho gaya. Not like that. So what you do, guys, there are almost 7 to 8 chapters which you simply ignore. I'm repeating, you simply ignore, and you give all your heart in doing those other chapters. But as you know, that weightage is there to given to all the chapters. And suppose you have studied very well and prepared those 20 chapters, suppose, and you have left all these 12 chapters. You have given all your heart in doing those 20 chapters. Okay. And you have attempted correctly also those questions if they are coming in exam. I am thinking that you also think that, though negative are there, but we don't go that side. We feel that हमने पूरा अच्छे से we have studied those topic, okay, we have done them correctly, but at the very next moment these 12 chapters are overlooked by you, whether you talk about biomolecules or you talk about chemistry in everyday life, or you talk about this environmental chemistry, or you talk about what do I say, polymers, and all inorganic chapters. Suppose you have simply overlooked them, okay, so what will happen? The 4 marks which you are getting out of doing those any one topic of those 20 chapters, which you are excelled thoroughly, which you have prepared thoroughly, will be, yes, will be deducted with 1 mark now. Why? Because the out of the question based on these 12 chapters are what? You are attempting negative. So वहां कमाया हुआ भी क्या होगा? You are making that negative. And no doubt you have studied a lot, but you have given all your importance in doing those 20 chapters only and just overlooked these 12 chapters. You have studied a lot, you have done a lot of hard work. Nobody denies that. But the strategy is missing here. I am repeating, the strategy is missing here. In order to excel your in order to excel in the exam, in order to ensure your every success, you are not allowed to overlook any chapter. I'm repeating, in order to ensure your every success, guys, you're not allowed to overlook any chapter, because weightage is there to all the chapters, isn't it? You cannot overlook. I am repeating, you are not at all allowed to overlook any chapter if you really want to ensure your success. And always remember this in your mind, that you are studying this to score well. So all you should take all the topics equally. No matter out of 32, 20 और 12 को बहुत ज्यादा है यार. एक दो चैप्टर बनता है, चलता है. बट इफ यू विल से इनऑर्गेनिक तो बोरिंग है, मगअप करना पड़ता है, अपने बस की बात नहीं है कि पॉलीमर कौन याद करे, बायोमोलिक्यूल ये भी ऑर्गेनिक में आते हैं, बट यस वी ऑलवेज टेक देम एट अ वेरी लोअर साइड. कौन याद करे? केमिस्ट्री इन एवरीडे लाइफ सो बोरिंग, ऑल फूल स्टडी देयर, ऑल फूल रीड्स देयर दोस टॉपिक. और एनवायरमेंटल केमिस्ट्री कौन पढ़ता है यार? बेटा कौन पढ़ता है? नहीं, आपको पढ़ना है. यू हैव टू ensure your every effort and convert your every effort into the very success, isn't it? So this should be the strategy, that you should look all the topics equally in order to ensure your every success. Because they say that, yes, they say that winners don't do things differently. They don't do anything, they don't do any different thing. I'm repeating, winners don't do any different thing. Rather, they just do the things differently. If you really want to stand out in the league of winners, what you should do, start thinking in a, yes, start thinking in a different way. Don't do anything different, just start thinking in a different way. So this is one of the different way I have given you, that treat all the topic, give respect to all the topic. Yes, सबको respect चाहिए. इनऑर्गेनिक गुस्सा हो गया तो एग्जाम में आपको क्लिक ही नहीं करने देगा करेक्ट आंसर. Are you getting my point? So respect to all the topics. Give proper time to all the topics. बहुत लंबा lecture हो गया. Come back to the topic we are doing on the screen, isn't it? So I hope you all guys are going to respect all the topics, and I will be trying to make my every best to make all the topic, all 32 topic very interesting to you, very ensuring your if the things are supposed to be learned in terms of example, I'll be giving you a very easy trick so that you will never forget it. And if some numericals are there, of course I'll be giving you very easy trick to solve them also. So all your 32 topics are equally respected here in this platform. So you also should give respect to all of them, all the topics. Done? फिर देखो कैसे नहीं बनती है बात. Okay, now look at the screen. Describe the importance of the following. Limestone is done. Cement. We were doing cement, guys. Yeah. कमिंग टू द सीमेंट. सीमेंट देखो, बिल्डिंग बनाते बनाते हमने क्या कर दिया? यस, आपका थॉट बना दिया. एंड आई होप you are going to work on that. So come back to the screen, all your eyes on the screen, guys. The cement, you know what is the cement? नो डाउट इससे क्या बनता है? बिल्डिंग. इसका जो रॉ मटेरियल है, वेरी इंपॉर्टेंट, दिस हैज बीन आस्क्ड मेनी टाइम इन नीट, व्हाट द रॉ मटेरियल्स ऑफ सीमेंट. रॉ मटेरियल्स, फर्स्ट वन इज लाइमस्टोन. हमारी बॉडी, हमारी बॉडी कैल्शियम की होती है ना? कैल्शियम गिव्स लॉट ऑफ सपोर्ट इंफ्रास्ट्रक्चर. सो लाइमस्टोन से याद रखो, यहाँ पे भी बिल्डिंग का इंफ्रास्ट्रक्चर. डन. देन क्ले. Clay is, provides a very strong cross linking. Clay, खाली हम स्कूल के प्रोजेक्ट्स नहीं बनाते. Clay is also, yes, cement, ingredient of cement. It is used to make cement. Then yes, lot of sand. I'm repeating, lot of sand, guys. And yes, all these are mixed very well in rotating mixture. Okay, rotating kilner. Rotating kilner, you keep this powder, this all three, mix it well, and yes, heat it also. Kilner, kilner मतलब क्या होता है? KILNER, kilner is भट्टी. वहां पे गरम करते हैं, and that keeps rotating so that it keeps mixing properly. And yes, guys, to that, what is there? Yes, to that, gypsum is added. I'm repeating. This you all guys must be knowing, I'm very much sure of, that gypsum is used to delay the settling time of cement. I'm repeating, gypsum is used to delay the settling time of cement in order to have a proper cross linking, in order to have a better quality cement. And yes, after that, all these are tightly packed under silos. You know, silos are what? Waterproof sack. Silos are waterproof sack, so that the cement, once they are prepared, can be transported easily without getting ruined. क्योंकि पानी इसका दुश्मन है. Once pani will be added to this, once water will be added to these cement, they are of no use. Trust me, they are of no use. That is the reason once they are formed here, they are very well packed under silos, which actually nothing but waterproof sack. Hope it is clear now. Now, guys, Portland cement, a very famous term you'll be hearing, Portland cement, which has been asked many a times, and just by Maro Tukka, we make a negative attempt to it. It is always asked the composition. I'm repeating, the composition of Portland cement, guys. What is the composition? Let me tell you here. See, this limestone, as you are heating in lime kiln, what is going to add? Calcium oxide. I'm repeating, it is going to add calcium oxide. I'm repeating, calcium oxide. Then it will be having SiO2, guys. SiO2. Then from clay, from sand SiO2, from clay, majorly you'll be getting Al2O3. And yes, clay consists of Al2O3 as well as SiO2. So silica is added over here, and then Al2 here. So these are there. Then guys, MgO is also there with the clay. Then we add Fe2O3 as well, guys. And lastly, we add gypsum. Yes, gypsum. So one is calcium oxide, second one SiO2, third one Al2O3, fourth one MgO, fifth one iron oxide, and sixth one what? Gypsum. How to recall it? Let me give you a very quick trick. So all your eyes on the screen, guys. How to recall it? Yes. हम सब अपना घर बनाते, and for all of us guys, whether छोटा घर, बड़ा घर, or the mansion, for all of us guys, I'm repeating, for all of us, our home is the castle. Yes, our home is the castle. Look at this, our home is the castle. CSCASTLE. A-L, castle. The spelling for castle is different, guys, but हमें तो क्या करना है? We have to remember is. Okay, so the trick for this is हमें तो क्या बनाना है अपना? Castle. चाहे वो MIG ही क्यों ना हो. So castle MIG. You know what is MIG, LIG, HIG? You can ask your parents. When we just go to different society to buy build up homes by which are actually built up by this builders, big builders, they actually used to make house in terms of looking a different income group as lower income group which is called as LIG, higher income group which is called as HIG, medium income group which is called as MIG. So चाहे MIG हो, LIG हो या HIG हो, हम सब के लिए हमारा घर क्या होता है? कैसल. और किससे बनाते हैं? सीमेंट से. बाकी सब कुछ चाहिए. घर बनाते किससे? हाउस किससे बनाते हैं? घर तो बिल्कुल हम लोगों से बनता है. So all your eyes on the screen. How to recall it? C for guys, calcium oxide. S for SiO2. Al for Al2O3. M for guys, MgO. I for iron oxide, and G for gypsum. These are the composition of cement. Thank you, beta. Thank you so much for the compliment. Thank you so much. यही तो चाहिए हमें. Just आपका motivation चाहिए बेटा. And trust me, in entire inorganic chemistry, you'll be getting such type of, yes, such type of easy and never forgettable tricks. Okay, easily memorizing tricks you'll be getting. Don't worry. In physical chemistry also, I'll be telling you the easiest way to crack the numericals in less time. Don't worry. For organic chemistry also, I'll be giving you proper trick proper trick to, yes, yes, to get into the reaction. Don't worry. So all you guys, all your eyes on the screen. So MIG, Castle MIG. Is this clear? C for calcium oxide, S for SiO2, A for Al2O3, M for MgO, I for iron oxide, G for gypsum. So guys, apart from gypsum, all of them are in their oxide form. Remember, apart from gypsum, all of them are in their oxide form. This is never going to let you forget this one. And yes, guys, one of the very important thing, let me tell you now. Let me tell you very important thing, but where to write? Yes, let us erase something out like this one. A very important thing, guys, I'm going to tell you that is been asked many times is, come on, all your eyes on the screen, guys. Yes. What is the ratio? Remember, this is a very important question, guys, about Portland cement. What is the ratio between calcium oxide to that of total oxide? Just now I told you that all these are in which form? Yes, all these are in their oxide form. So this is one of the very important thing, guys. You are supposed to write down. Yes, you are supposed to write down the ratio. Always remember, in order to have the cement to be best quality, this ratio should be at least 2 or more. Minimum ratio 2 चाहिए. मिनिमम रेशियो क्या चाहिए? 2. कैसे याद करोगे? हमारी हमारी बॉडी कैसे मजबूत होती है? Ritik Narvare, welcome to the class. He's saying very nice tricks given, ma'am. Love them. I love you all guys who are studying right with their all heart and yes, all your brain towards the screen. I'm so happy, guys. If you all the guys give such type of compliment, that's energize me too much. So thank you so much. Thank you so much for watching this. Please do like the video if you all guys have not liked it. If you have not shared it, come on, do so. And yes, if you have not subscribed the channel, do that. Press the bell icon also in order to have further notification. So all your eyes on the screen. कैसे याद रखेंगे बेटा? Our body is what? Yes, our body is what? Our body is made up of calcium, isn't it? बोलते हैं ना, building block of our body. हमारी बॉडी में क्या है मेन? हड्डियां। हड्डियां किससे मजबूत होती है? कैल्शियम। बिल्डिंग की भी, बिल्डिंग को भी क्या चाहिए? कैल्शियम। सो कैल्शियम ऑक्साइड टू ऑल द रेशियो, जितना सारा मिला कि उस ऑक्साइड का डबल होना चाहिए कैल्शियम। होप यू आर नॉट गोइंग टू फॉरगेट, पक्का? गुड. And then guys, there is one more thing. If you talk about the ratio of SiO2 and Al2O3, see, we are adding sand, we are getting clay. We are adding sand, we are getting clay. The clay composition of clay is, you know what? Al2O3, SiO2 and H2O, guys. So just look at this. Even this has got a ratio of what? Yes, SiO2 is much more than Al2O3 in it. So SiO2 has to be more. Sand है ना? आप सबने देखा होगा घर बनता है तो sand से. So sand should be, yes, what sand should be more. So the S for sand, as for stronger, stronger मतलब strength here मतलब ज़्यादा. So the ratio should be right from 2.5 to 4. इज दिस क्लियर गाइस? आप ऐसे भी याद रख सकते हो, अल्फाबेटिकली ए के बाद एस, एस बहुत ज्यादा. ओके, सो द वन विच इज ज्यादा इज, yes, of course, the ratio also zyada. So I hope you are not going to forget this. So let me click, just give a quick look on this. What the question which can be asked on this cement is, first, the very first question will be, guys, what are the raw materials? So you have to remember limestone, clay, sand. They are the raw materials. And yes, in order to just delay the settling time, which is very much required for cement, you add gypsum. Because जितना धीरे धीरे सेटल होगा उतना stronger the network will be formed. You know, silica strong enough to form the network by all its four bond. So utna better the network of the cement will, between the cement, composition will be formed, and utna better quality the cement will be of. Okay. Now there is a very famous cement called as Portland cement. The composition of this is this. Okay, guys, where it is calcium oxide, silica, Al2O3, MgO, Fe2O3, and gypsum. How to remember this? For all of us, our home is like castle. So whether it is LIG, HIG, or MIG. So you have to, because most of, in the world, the most common one is what? M for most common as well. So M for MIG, medium group ka hi, medium income group ka hi sabse zyada जनता hai. So you have to write down castle MIG. But this C stands for calcium oxide, H stands for silica, A stands for Al2O3, M stands for MgO, I stands for Fe2O3, and yes, this G is there to delay the settling time of cement. And yes, apart from that, this G is what? This calcium sulfate 2H2O gypsum. Apart from that, all of them are in the oxide form. So one of the interesting thing which you need to remember is the ratio of calcium oxide to that of all is almost should be twice. Almost twice. Means if you talk about the percentage, this should be 60%. Okay. And all of them should come under what? 40%. Majorly, minimum ratio I'm talking about. But better you remember it by 2 is to 1 ratio. And if you talk about SiO2 and Al2O3, this has to be 2.5 to 4. Is this clear, guys? Pakka, just have a quick look on the screen again. Faster. Faster. I'm going to erase it because very soon. Jaldi se kar lo. Yes. Now, all your eyes on the screen for plaster of Paris. This is something which you have been studied so far in class 10, all you 11 guys. Isn't it very common? Plastering, plaster of Paris, bust, statues are also made of it. For interior decoration, also we use it. Isn't it? Yeah. So, plaster of Paris is made from gypsum. How do we represent gypsum, guys? Yes. This is gypsum. Okay. Now, just heat it at around 120 degrees centigrade. You are going to get plaster of Paris. Just a sec, let me, where is the eraser? All your eyes on the screen, guys. Yeah. Half H2. This is actually called as POP or plaster of Paris. What does that mean? Aadha molecule cut gaya? No. Between any two CaSO4 unit, there is one water molecule present in between. That it means. Okay. Now guys, this you must have studied in class 10. आगे बढ़ते हैं. Guys, it by mistake, if you heat it even little longer and slightly, the temperature suppose reach to 200, you know what will happen? All the water will come out. I'm repeating, all the water will come out. And this particular anhydrous CaSO4 is actually of no use. Therefore, it is called as dead. I'm repeating, burnt, dead burnt plaster. It loses all its plastering ability. I'm repeating, it loses all its plastering ability. Therefore, the name is given so that this is dead burnt plaster. Hope it is clear. Now, suppose you even do not switch off the heating facility and keep heating it even higher temperature. You all guys know that sulfates of alkaline earth metal are going to decompose. Yes. So this will decompose as oxide. You'll be getting SO2 and O2, which together sometime written as SO3 also, guys. Okay, I hope it is clear. So this is the common reaction of decomposition on strong heating. Decomposition on strong heating of alkaline earth metal sulfate, guys. Remember, alkaline earth metal sulfate. All of them do give their respective oxide SO2 and O2 on strong heating. But yes, as you know that thermal stability increases down the group. So just keep on increasing the temperature down the group. Okay, done. आगे बढ़ते हैं. Now, by the time you all guys read the question on the screen, I just want to have few sip of water. Okay, nice guys. Let's come back now. Why are lithium salts commonly hydrated? I'm repeating. Why are lithium salts commonly hydrated and alkali, those of other alkali ion usually anhydrous? Yes. One of the very important thing, or you can say differentiating factors with which we call lithium as Lanka Bhedi. Okay, guys, this is unlike two alkali metals, but very much like to that of alkaline earth metal. But before that, let me tell you why it happens so. See, guys, water is what? A covalent molecule. Water is a covalent molecule. Say this how it looks like the spherical electron cloud and all of water molecule. So what happened? Lithium being small in size, okay, and as it is small in size, it has got very high charge density. What is charge density? Charge upon size, guys. Okay. See, all alkali metals, as you talk about charge, is same plus one. But lithium is the smallest in size amongst all. You'll be saying, ma'am, hydrogen is not an alkali metal. Don't do that. Okay. So lithium has got highest charge density. And because of that, you know, the tendency to polarize this, yes, tendency to polarize this spherical molecule is too much. Because of that, you know, because of lithium, this negative part, this electron cloud get polarized, or you can say distorted, or this comes closer like this guys comes closer to this way. Okay, and because of this actually it is called as this get polarized, and because of this water molecule are always present with the salt of lithium as a hydrated one, and we call them as water of crystallization, guys. Water of crystallization. This is how it gets attracted towards it. Okay, so This is they are present as water of crystallization. And how do we represent them? We represent them as LiCl dot 2 H2O. This is the salt, guys, and this is water of crystallization. I'm repeating, this is the salt, and this is how the water of crystallization are represented with the help of a dot. Hope it is clear. Now let me one thing tell you about it, that other alkali metal, they have charge plus one, no doubt, but they are in every period the size is maximum for them. So yes, size is maximum for them. So the charge density is very less, and yes, all other alkali metal, this is the reason, cannot polarize the water molecule, and that is the reason they do not exist in this crystallized water of crystallization form, or you can say hydrated salt. A salt having this water of crystallization, what do we call? Hydrated salt. Is this clear? Now, all alkaline earth metal, as you know, the size is comparatively lesser than alkali metal. So, charge density is higher. So much capable to polarize the water molecule, guys. Pakka? Clear? That is the reason they all exist in hydrated salt form. Now, there must be a question in your mind that NaCl to chipchipa ho jata hai at the time of what? Rainy season. Does it absorb moisture? No. It cannot absorb moisture, but yes, the impurities present along with them. I'm repeating, the impurities present along with them, like magnesium chloride and all, they absorb moisture and make it hydrated. Okay, done. Good. Sorry, have this. Now, guys, the next question on the screen is, why is lithium fluoride, I'm repeating, why is lithium fluoride most insoluble in water, whereas lithium chloride soluble not only in water but also in acetone? You must have heard a very common known fact like dissolve, like guys. So you all know, guys, water is a polar substance, isn't it? So those which are ionic will very well dissolve in it. Similarly, yes, acetone is what? Acetone is, yes, what type of solvent it is? Non-polar one. And a compound which is not that polar will also be dissolved in that, as we go with like dissolve like, isn't it? That. Now have a look at LiF, guys. It is said that it is insoluble. Li is insoluble in water. Why? See, guys, if you compare the size of lithium and that of fluorine, both are smaller. So you can say that a small anion stabilizes a small cation and vice versa. Therefore, higher is the lattice energy. Or you also can say both are smaller, that is, the size difference is least. And size difference is least, so better is the packing. And guys, better is the packing, so higher is the lattice energy. And if higher is the lattice energy, yes, lower is the solubility. Therefore, lithium fluoride is insoluble in water. I hope it is clear. Pakka. It is clear. So, because in order to get it soluble, in order to get it dissolved, hydration energy should be more than lattice energy. But in this case, because of the very well crystal packing, actually lattice energy is more than hydration energy. Therefore, it is insoluble, guys. Okay, this is the explanation for LiF. Now, let us see the explanation for LiCl, guys. Li, just now we had seen that very small in size, has very high charge density at the same time. Okay. And because of the charge density, high charge density, it can very well, yes, it can very well polarize. It can very well polarize this Cl minus ion towards itself. So you had seen that the electron density is somewhere in between Li and Cl, which actually happens where? Where the bonded pair of electron or the electron density is more in between the bonded atom. Yes, it is there in covalent compound. So because of this polarization due to high charge density of lithium, LiCl has acquired a covalent property. Okay, it has got some extent of covalent property. Because of that, guys, it is able to dissolve in acetone. I'm repeating, because of that, it is able to dissolve in acetone. Done. And yes, at the same time, Li plus and Cl minus, which is an ionic solid also. So it is soluble in water as well. So these are the two explanations for which LiCl is soluble in water as well as in acetone. Hope it is clear, guys. Pakka. Good. Now the next question on your screen, explain the significance of sodium, potassium, magnesium and calcium in biological fluid. Let me tell you. Magnesium we all know is present where? Chlorophyll. So again you can write lot many things out of that. Now calcium is present in bones, teeth, enamel. So more than enough. Now let us look at this, guys. Let us look at sodium and potassium, which you might not have done before. Okay, let us look at this. But before I tell you this, can you tell me what is sodium and potassium pump, guys? Can you tell me what is sodium and potassium pump? Yes, what is sodium and potassium pump? फटाफट से बताओ. Yes, all these are nerve system. All of you are future doctors. You must know about sodium and potassium pump. This nerve system in our body actually work on sodium and potassium pump, isn't it? The concentration of sodium and potassium is going to, yes, the concentration of that is going to convey the message in the terms of nerve impulse and all. Okay, guys, I hope it is clear. Pakka it is clear? Done. Now let us see sodium and potassium pump. Or what this the significance of sodium and potassium. See, this is sodium, this is potassium. You know the role of sodium is, guys, it is actually more important. Remember, this is actually more important, guys, because this is actually present outside the cell first of all. Done outside the cell, or you can say these are primarily found outside the cell and where? In blood plasma and other interstitial fluid. In blood plasma or other interstitial fluid, guys. ध्यान से सुनना. And yes, they play a role in transmission of nerve signal. Or you can say स से सोडियम एंड स से समाचार. सिग्नल मतलब क्या? समाचार. तो they give nerve signal. Don't worry, all your eyes on the screen. You are going to get a proper trick so that after this only you will remember it forever. But yes, for that, I'm repeating. All your eyes on the screen. Okay? तो जैसे सेना है ना, सेना, और सेना stands over where? LOC, LAC, line of actual control between China and India, line of control between India and Pakistan, isn't it? So, सेना कहाँ रहती है? At the boundary, बाहर, बस बाउंड्री के वहां पे. उसी तरह सोडियम कहाँ होता है? सेल के जस्ट बाहर. यस, सेल के जस्ट बाहर. वेयर? इन द ब्लड प्लाज्मा एंड अदर इंटरस्टिशियल फ्लूइड. क्या करता है, गाइस? क्या करता है? यस, दिस गिव्स समाचार, नर्व सिग्नल. एस फॉर सोडियम, एस फॉर सिग्नल, सिग्नल फॉर समाचार. अलर्ट करता है. आई होप इट इज क्लियर. मजा आ रहा है? गुड, मजा आएगा. एस फॉर सोडियम एंड एस फॉर शुगर कंट्रोल. It also does what? Yes, it transports sugar or control sugar, or you know, कीप अ चेक ओवर शुगर, कितना अंदर कितना बाहर काइंड ऑफ। एंड शुगर को करता है तो शुगर के साथ और हम लोग क्या खाते हैं, प्रोटीन भी खाते हैं। यस, दैट इज अमाइनो एसिड ऑल्सो। याद रहेगा, पक्का से याद रहेगा। एंड देन वन ऑफ द इंपॉर्टेंट थिंग, इट ऑल्सो डज व्हाट यू नो गाइस, it regulates flow of water. I'm repeating, it regulates flow of water, flow of water across cell membrane. कैसे याद रखोगे इसको? How will you remember this? All those this army people and all, कोई भी इंट्रूडर्स आते हैं, इन्फिल्ट्रेशन होता है, इंट्रूडर्स होता है, कोई भी आतंकवादी, उनको आने देते हैं क्या? नहीं। ओके, नहीं, दे कीप अ चेक ऑन देम, इजंट इट? तो बाहर से अंदर कितना पानी आएगा वो कौन चेक करेगा? सोडियम। ये तो हमारी सेल की सेना है। आर यू गेटिंग माई पॉइंट? दे विल डिसाइड कि वाटर अंदर जाएगा या नहीं। सो आई होप सोडियम का रोल बहुत अच्छे से याद हो गया होगा, बहुत अच्छे से याद हो गया होगा। लेट मी रिपीट इट वंस अगेन। वेयर डू दे प्रेजेंट? सोडियम दे प्रेजेंट आउटसाइड, they present outside. S for sodium, S for passing signal. What type of signal? हमारी बॉडी में तो सिग्नल कैसा होता है? We all have nerve signal. So yes, they will be, yes, giving you nerve signal. They will be controlling nerve signals, guys. Thank you so much. Pavni, Pavitra is saying that very nice trick, ma'am. Thank you, beta. Thank you so me. Really very nice to see you all guys here. Really grateful. Come on, all your eyes on the screen back. आउटसाइड, बाहर रहते हैं सोडियम, कहाँ पे? इन द, यस, इन द सेल फ्लूइड, दैट इज प्लाज्मा, ब्लड प्लाज्मा एंड इंटरस्टिशियल फ्लूइड। क्या करते हैं? एस फॉर सूचना, एस फॉर समाचार, एस फॉर सिग्नल, सेना जैसे। ओके, एस फॉर शुगर कंट्रोल, और शुगर है तो खाते हैं साथ में, प्रोटीन भी तो खाते हैं, अलग कर देते क्या? दाल वाल सब साथ में, प्रोटीन का क्या? अमाइनो एसिड। देन दे कंट्रोल फ्लो ऑफ वाटर। हमारे देश में कौन आएगा कौन नहीं आएगा, इस बेसिकली ये सेना वहीं पे, तो समझ रहे हो ना? फ्रॉम पास्ट 2-3 months, what is there in the news? Yes, we should respect them. They are doing lot many things for us, guys, and हमें इनसे सीखना चाहिए. We should learn lot many things from them. They never say no, kabhi हार नहीं मानते. They always keep standing over there at the sake of their family and everything, at the sake of their country. वो वहां खड़े रहते हैं अपनी फैमिली से दूर, isn't it? हार नहीं मानते. So हमको भी खूब पढ़ना है, हार नहीं मानना है. And we have to become the great doctors, okay? And yes, serve the nation. वो वहां पे दुश्मनों से लड़ रहे हैं, हम बीमारी से लड़ेंगे. And yes, this is how we will serve the nation. Come back to the screen. So sodium, the role of sodium is clear, bahar and all, done. Now what is the role of potassium, guys? Have a look at the screen. Potassium, first of all, ये बाहर रहता है तो ये अंदर रहता है. This is inside the cell. Inside the cell we use the term penetration, right? P for potassium, P for penetrated. So potassium are present, penetrated the cell, that is inside the cell. ये याद रहने वाला है आपको, पक्का. Then they activate, their role is what? First of all, they are present inside the cell. How to recall that? P for potassium, P for penetrated. Done. What is the role, guys? They activate many enzyme. I'm repeating, they activate many enzyme, guys, which are responsible for oxidation of glucose to produce ATP, adenosine triphosphate. You guys know this ATP is actually what gives power. We get power out of it. So P for potassium, P for power. So the one which activate the enzyme and actually make them produce what? Power. So this is how the role of potassium is going to be remembered by you. P for potassium and P for power. Done? I know, guys, you are not going to forget this. And moreover, apart from that, have a look on the screen. Yes, sodium potassium pump. Yes, sodium potassium pump. Due to the difference, you just got to know that sodium is more outside the cell, potassium is penetrated, that is more inside the cell. Done. So there is a quite difference in the concentration between them outside and inside, isn't it? So this difference in concentration across the membrane is dealt under sodium potassium pump. I'm repeating, sodium potassium pump, guys. And this is how all the nerve signal is transmitted. Done. I know you guys have enjoyed it a lot. Pakka, pakka. Then just pata bhi to chale. That's, oh my god, I've not seen these all messages. Thank you so very much, beta. All your studies, actually, you guys, your comments are our inspiration. We do are human being. हमें भी पावर चाहिए. ओके, सो योर कमेंट्स आर एक्चुअली आर इंस्पिरेशन. एंड आप लोग ऐसे ही अच्छे से पढ़ते रहो और हमें इंस्पायर करते रहो, सो दैट सच टाइप ऑफ ट्रिक इन एंटायर केमिस्ट्री, वेदर यू टॉक अबाउट ऑर्गेनिक, इनऑर्गेनिक और फिजिकल, different as per the requirement of the topic, I will try to keep bringing such easy trick in order to make it memorable. जो ये कंफ्यूजन टर्म आता है ना केमिस्ट्री के साथ, ये हटा देंगे अपन, ये हटा देंगे, खत्म कर देंगे बिल्कुल. तो सी फॉर केमिस्ट्री, सी फॉर कॉन्फिडेंस होगा, ना कि सी फॉर केमिस्ट्री, सी फॉर कंफ्यूजन. रिमेंबर दिस, से सी फॉर केमिस्ट्री मतलब सी फॉर कंफ्यूजन यार, बहुत सारा कंफ्यूजन. वी आर गोइंग टू रिमूव दैट एंड वी आर गोइंग टू मेक इट वेरी सी फॉर कॉन्फिडेंस फॉर सी फॉर केमिस्ट्री. ट्रस्ट मी. थैंक यू बेटा. So guys, let us go ahead now. Now look at the screen. What happens when sodium metal is immersed in water? Very simple, guys. Sodium, on immersing with water, it forms NaOH, and yes, H2 is there. This reaction is extremely exothermic, and you all guys know that hydrogen gas is highly inflammable. And as the reaction is extremely exothermic, that heat which is generated in the reaction is sufficient enough to cause burning of this hydrogen. And yes, this all happened with a sudden explode. Whenever, suppose if you take a trough, fill it with water, fill it with water, and just pour sodium lump to that, it is going to explode with a very sound, as if you have just burst a cracker. You don't have to do, you can watch the video, उसी से काम चला लो. क्या मतलब है unnecessarily ऐसा कुछ करने से? Good. Now guys, look at the screen. Sodium metal is heated in abundance of air. Very interesting question, guys. Very interesting. See, sodium metal, or if you talk about lithium metal, or if you talk about rubidium, yes, or cesium, guys, how do they react? Let me tell you. But before that, let me check the message of, okay, Arpita. Welcome to the class. Vidhi Dubey has joined us just now. Welcome, beta. How are you, Vidhi? This is for you. All you guys are most welcome to the class. That's very nice of you. सब मजे से पढ़ रहे हैं. That's really encouraging to me, guys. Come on. If you have not shared it to your all your friends, do that without a delay, guys, so that they also can be the part of this wonderful lecture. Yes, come on, invite all of them, guys, and all your eyes on the screen. See, guys, let us discuss what happens when alkali metal, I'm repeating, when alkali metal are heated with oxygen. What happens? Let us see. First of all, guys, if limited oxygen is there, remember, if limited oxygen is there, all of them are going to form their oxide with formula M2O. Whether you talk about Li2O or you talk about, yes, Ne, or you talk about potassium, or you talk about rubidium, or you talk about cesium. Okay, but as you know, this is Lanka Bhedi. I'm repeating, this is what? Lanka Bhedi. So this will not only react with oxygen, at the same time it will be reacting with nitrogen also. Just now we had seen. Done. So this is how they are going to react with limited supply of oxygen. Remember guys, if oxygen is there in excess, let us have a look on the screen. What will happen? See, lithium ko chhod ke, if it is sodium, it is going to react with this. First, it will of course form Na2O, which further react with O2, and this will give Na2O2 guys. What is it? Yes, this is sodium peroxide guys. And remember why lithium is not, but lithium will not form so. Why? Because this peroxide ion O2 2 minus is bigger, much bigger than the size of lithium. And we know that a bigger anion stabilizes a bigger cation. Okay, so being bigger in size, peroxide cannot stabilize the small lithium in the 3D crystal, and therefore it is not forming. Whereas the size of sodium and that of peroxide is somewhat comparable, that peroxide ion is able to stabilize sodium ion and that 3D crystal. I hope it is clear. Is it clear, guys? Good. Now, guys, if you supply excess oxygen to potassium, rubidium, or cesium, guys, I'm repeating, if you supply, then what will happen? All of them are going to make superoxide. Just try to get the difference. Here it is K2, here it is KO2. That is O2 minus, the oxidation state of oxygen in superoxide is taken as, guys, minus half. It is taken as minus half, whereas the oxidation state here it is minus 2, or the oxidation state here in peroxide is minus 1, guys. Okay, now all your eyes on screen. So this KO2 will be formed, RbO2 will be formed, CSO2 will be formed, guys. So these are the respective superoxide. Is this clear? Now all of them are what, guys? Yes, you all guys know that there is an unpaired electron here. Because of that, this is paramagnetic, and of course because of that it is colorful, because of the single electron, guys, because of the single unpaired electron it is colorful, and all of them are orange yellow, orange or yellow depending on the amenities. They are orange or yellow in color. I'm repeating, they are orange or yellow in color. So these are the superoxide. Again, why sodium do not form superoxide, or why they do not, these three do not form, like preferably form peroxide? The reason is same. A bigger anion stabilizes a bigger cation. So the size of the superoxide anion, look at the screen, guys, size of the superoxide anion is bigger enough to stabilize the bigger cation, whether you talk about potassium or you talk about rubidium or you talk about cesium. Hope it is clear, guys. This is very well clear to you. Good. Wonderful of you. Now the next one. By the time, just have a look at the screen. जल्दी से देख लो बेटा, faster. Done. Great. All you have, all your eyes on the screen now, guys. Now the next question. एक second. There's something left. We could not discuss it. No worries, we are doing it. So have, yes guys, have a look at the screen. The last one. Sodium peroxide. What happens when sodium peroxide gets dissolved in water? Just now you had seen the formula of sodium peroxide is what? Na2O2. Is this clear? The formula is Na2O2, guys. See what happens when you dissolve Na2O in water. It forms NaOH, alkaline. That is very clear. When excess oxygen is there, what will happen? What will happen, guys? This will give you NH, of course, without fail. You'll be getting here what? NaOH. Apart from that, you'll be getting here H2O2, guys. And you know this H2O2 hydrogen peroxide. Yes, this also gives H2O after decomposition in presence of light. This undergo further decomposition and gives water and O2. Because of production of O2, this is also used as under the name oxone to produce oxygen. Remember, this is used to produce oxygen, guys. Now look at the screen. We have the very next question on the screen is the ionic mobility of alkali metal ions are in the following order. Ionic mobility is what? Yes, it is seen in aqueous solution. First of all, ionic mobility is seen in aqueous solution. This has to be very, very clear to you guys. Then, suppose you talk about Li plus. This has a, all these ions have a very good tendency because this is what plus charge. Water is a dipole. So they have a very nice tendency to get attracted by, suppose we represent water like this. Dipole है तो minus और yes minus है तो plus होगा ऐसा. Isn't it? So because of that, this lithium ion get hydrated, guys. It get hydrated like this. That is, it is surrounded by water molecule. Remember, guys, being small in size, you know what happens here? But are all your eyes on the screen? This is something very, very important. So the very first layer, because this does not have MTD orbital, remember, the very first layer has got 4 water molecule. And because of that, guys, it can further attract more water molecule and one more layer of water forms like this. So this is this hydrated ion. And because of small size, the size of hydrated ion is bigger. It is much bigger, guys. And if you talk about the size of hydrated ion, I'm repeating, if you talk about the size of hydrated ion, the relation is something like size of cation is inversely proportional to size of hydrated ion. Remember, smaller the size of cation, bigger will be the size of hydrated ion, guys. I'm repeating, smaller the size of cation, bigger will be the size of hydrated ion. Is that clear? और कोई कितना बड़ा होती जाए, will he able to walk properly? I mean, suppose we are traveling and suppose इस bag इस हाथ में भी दो चार bag, here also दो चार bag, दो चार कंधे पे, okay, okay, कंधे पे, then what will happen? Will I able to walk properly? No. Similarly, lithium being very small in size gets surrounded by so many of water molecule. It is not able to walk properly, or you can say it is not mobile. So the ionic mobility decreases, or you can say smaller the size of cation. I am repeating, smaller the size of cation. Yes, bigger the size of hydrated ion and smaller is the ionic mobility, or this is related straight away like this. So you can say smaller the size of cation, smaller the ionic mobility, or bigger the size of cation, bigger the ionic mobility. And that is the reason you all guys know that cesium plus is bigger one. So ionic mobility is also bigger here. Whereas L for lithium, L for lower, yes, size, so lower ionic mobility. So what you have to do, you just have to remember this, memorize this. So this is the trick to memorize this one, guys. So write it this way only. Size of cation inversely proportional to size of hydrated ion, which is further inversely proportional to ionic mobility, or in other words, you can say size of cation is directly proportional to, yes, ionic mobility. आ गया? अच्छे से आ गया? Very good. Have a look at this for a moment. Faster. जल्दी से कर लो, जल्दी से लिख लो guys. Now, all your eyes on the screen, guys. Fast, fast, fatafat se. The second question is, lithium is the only metal that can form a nitride directly with lithium. That can form a nitride with lithium? No. That can form a nitride with nitrogen. अच्छा नहीं नहीं ठीक है नाइट्राइट विथ नाइट्रोजन यस नाइट्रोजन राइट नाइट्रोजन हियर ओके क्लियर we have already seen that lanka bhedi when you react it with air it's not only going to react with oxygen but at the same time this will be reacting with nitrogen also and why it is happening what is the reason you know guys the oxidation state of nitrogen is zero here okay and when it forms Li3n here the oxidation state is -3 so you can see that nitrogen is very well undergoing what guys reduction I'm repeating this undergo reduction guys and as you all guys know that lithium is the wonderful reducing agent that is the reason this can reduce nitrogen right from its elemental state to nitride होप इट इज क्लियर आया समझ में पक्का फटाफट से लाइक करो शेयर करो सब्सक्राइब करो देन जल्दी समझ में आए तो डू दैट विदाउट एनी डिले फास्ट गाइस जल्दी जल्दी कर लो और इसको कैसे रिकॉल करोगे लिथियम लंका भेदी अनलाइक ऑल alkali metal but like to that of alkaline earth metal nice of you guys बहुत अच्छा just all your eyes on the screen थैंक यू कालिंदी थैंक यू सो मच बेटा गुड मजा आ रहा है आप लोगों को मुझे भी मजा आ रहा है मुझे भी मजा आ रहा है हैव योर आईज ऑन द स्क्रीन नाउ it is written as E naught for M2 plus 2E that is M that is reduction potential this we call as reduction potential is nearly constant okay before we go ahead for this let me clean the ink present on the screen see guys in order to have always remember this reduction potential will be decided reduction see what is reduction potential first of all let me tell you it is tendency it is tendency to yes it is tendency to undergo reduction isn't it so what will happen these the reduction potential of generally these alkali metal is extremely negative because they do not undergo reduction yes they undergo oxidation and reduces other getting my point extremely negative reduction potential they have okay so what are the factors which decides where the sign of this reduction potential is first one delta heat of sublimation remember which is always going to be positive आपका पास solid lump है you have to convert it into vapor form so in order to that you have to break on those metallic bond so you'll have to supply energy therefore this is generally positive guys the very second one coming under that is ionization energy guys that also you guys know that is positive isn't it that is always a endothermic positive तो ये दोनों तो positive हो गए and the third one which is actually the decisive one guys is hydration energy I'm repeating is hydration energy so as far as we have to see the reduction potential of metal we should see these three values And most of the time for alkali metal it happens because of the tendency to get hydrated. The hydration, a lot of hydration energy is liberated because water is a polar solvent and they are positively charged, guys. So they attract, they get hydrated, and a lot of energy is liberated, which is, as energy is liberated, so as per thermodynamic, a negative sign to them and a positive sign to them, guys. So what happens generally, this overcome these two, and that is the reason they have a strong tendency to, yes, act as a reducing agent. Or you can say the reduction potential is negative. Got it? Now, guys, all your eyes on the screen. So this is all about like more. There is a like hydration energy, ionization energy, and sublimation energy is all clear. Now have a look at the screen now. But it is said that for as you compare calcium, strontium, and barium, it is nearly constant. See, guys, in case of these, you have to take out second electron also, and always remember that second, I'm repeating, second delta HIE is almost twice that of first delta HIE. Second ionization energy of them is twice to that of, yes, it is twice to that of first ionization energy of them. So the overall value, I'm telling you, the overall value, or you can say the combined effect, because something is being added, something is having negative sign, the other are having positive sign. So the combined effect comes out to be almost same. I'm repeating, the combined effect of this, of all factors, is approximately same. Therefore, electrode potential, guys, is also same. Done. Good. Now the next question on the screen, a solution of Na2CO3 is alkaline. Very simple, guys. Add water to Na2CO3. It will be giving you NaOH, which is a strong base and a weak acid. And therefore, it has to be what? Alkaline in nature. Now the next one. Are alkali metal mostly prepared by electrolysis of? Yes, yes, because no better reducing agent अवेलेबल, दे आर द बेस्ट वन, कोई और उन्हें रिड्यूस नहीं कर सकता. Therefore, guys, you have to take molten form and then electrolyze them, and then it is, yes, basically for sodium you should write this, okay, and Cl2 gas. याद है? Yes, याद है this one? Very good. Now the next, is sodium more important for survival than potassium? Yes. Sena, Sena, can we survive without those armies standing there either on LOC or LAC? No. So, bus, sodium is more important. As for sodium, as for survival, as for important for survival. Survival के लिए important है. Done. Now the next one, reaction between water and Na2O2. Just I told you, Na2O2 when dissolved in water will give you NaOH and H2O2. And if it is done in an open container, it is soon will further give you this. So this is how. Now superoxide, very very important one, guys. Superoxide on dissolution in water, no doubt potassium है तो KOH तो होगा ही, or H2O2 will also be there, and yes, oxygen will also be there. So a lot of oxygen is of course going to be formed. Now this Na2O2, guys, is a basic oxide. The CO2 is an acidic oxide, guys. And together, I'm repeating, together they are going to, when acid and base combines together, what happens? Yes, salt kind of things forms like this. Done. आया समझ में? Good. Come on, guys, come on. If you have not liked the video, फटाफट से like कर लो, जल्दी से like कर लो. Very soon we are going to end this particular discussion. फट से, come on, guys, without any delay, like, जल्दी से. Share to your friends. Share it. Call all your friends and ask them, जो बचा कुछ है वो तो देख लो यार. And then download it and watch it later. Pause, play, and watch the entire video. Prepare the entire topic. Okay. And those who are thinking that 29 question discuss हो रहा है पहले का क्या, yes, I have made the entire video on discussion of S block element along with the questions of NCERT. The entire chapter is very well discussed, guys, and this is the third video under that. And yes, link for the previous video on S block of mine is given in the description box. Okay, so all your eyes on the screen, guys. Now just look at beryllium sulfate is soluble in water, whereas beryllium oxide is barely soluble. Okay, guys. If you compare, let us compare the size. Beryllium is very small. Sulfate is very, very big. Very, very big size, guys. That is, the difference in size is very high, isn't it? Is very high. High difference, so you can say that a bigger anion cannot stabilize a small cation, or you can say ineffective, I'm repeating, ineffective crystal packing, or you also can call it as poor crystal packing. So it is very, very clear that beryllium and sulfate, this beryllium sulfate have got a very poor crystal packing. And if the poor crystal packing means lattice energy is very less, guys, which is quite overcome by hydration energy. I'm repeating, quite overcome by hydration energy. Vidhi Dubey, okay, thank you, beta. बहुत अच्छा लग रहा है, you all guys are studying so quietly with all concentration on the board, I mean on the screen. That's nice, guys. Great. Kalindi, this is for you, and this is for you guys, all you sitting out there. So guys, have a look at this on the screen. So in order to a particular substance to get dissolved in water, its hydration energy should be more, and that is happening here in case of BeSO4. Therefore BeSO4 is soluble. Whereas if you see the size of beryllium, if you see the size of beryllium and oxygen, guys, beryllium and oxygen, both of them are comparable size. Both of them are small. If both of them are small, the delta size, let me change the color of the pen here. See, the difference in size is less, and a very well a small anion stabilize a small cation. So very effective packing in case of BeO. Wonderful strong packing means very high lattice energy, which is going to very well overcome the hydration one. And yes, if lattice energy is more, it is going to be barely soluble in water. Clear? Done. Good. Now look at this one. BaO is insoluble in water. Same kind of question. BaSO4 is barely soluble. See, barium is big, guys. It is big. Oxide is small. Again, look here. Large difference in size. Large difference in size means what? Poor crystal packing. Okay. So less lattice energy, which is truly overcome by hydration energy. So it is soluble. Whereas Ba is big. Sulfate ion is also big, guys. Both of them are big. Both of them are big means what? Difference in size is small. Effective crystal packing then. And yes, that will result what, guys? Very high lattice energy, guys. Very high lattice energy. Not going to be overcome easily by hydration energy. Very nice of you all, guys. Thank you so much. Thank you, beta. Thank you so much. Done. That is the reason it is not. BaSO4 is not soluble. And that is the reason many of the time, what do we say? BaSO4 is precipitated out. यही वाला reason है. This is only the reason for that. Now the next one, solubility of lithium iodide is more than that of Ki in ethanol. Again, Ki, lithium iodide is more than that of Ki in ethanol. See guys, lithium being small in size, very high charge density, isn't it? And iodide ion is very big anion, guys, like this. Okay. So because of that Fezan rule, do you remember Fezan's rule? लगा दो, फटाफट से लगा दो यहाँ पे. So it can polarize this. Yes, it can polarize this negatively charged ion like this. And more of the electron density are actually between the bonded lithium and iodine now. That is going to make this particular one as more towards what? Covalent character. That this ionic compound will have extent of covalent character also, guys. And therefore it can dissolve in water, guys, as well as this get dissolves in ethanol. Clear? Whereas Ki, the charge density is least, guys. So it cannot polarize it that level as lithium does. So it remains more of the ionic, more towards that of ionic, and therefore like, yes, like dissolves like does not dissolve in unlike. So this is polar, yes, non-polar. So do not dissolve here. Done. आया समझ में? This is for you if आया. नहीं आया? आया? Good. Now look at the screen now. Which of the following alkali metal has the least melting point? See guys, what are the factors? कभी भी ऐसे question, go for the reason. Go for the reason, guys. What are the factors which will decide this? Metallic bonding. Let us have a look at the metallic bonding, guys. You know, these are in any period, if you compare their sizes, maximum alkali metal, maximum in period. Okay. Therefore, the outermost electron is loosely bound. And because of that, you know what happened? Suppose if you talk about, say, sodium, its electronic configuration is 281 and here is the nucleus. So what happens? This together, nucleus and the inner electron exist as kernel, intact particle, where this loosely bound electron is just adhere to it, just चिपका हुआ है. Loosely bound है तो क्या होगा? Simply adhere. I am repeating. If it is loosely bound, what will happen? It will be simply adhere to it. Is this clear? Now, because of that, all these metal exist. You know how they exist like this, guys. Okay, and these are kernels are actually attracted with each other through these loosely bound electron, which is also called as mobile electron, guys. And yes, this internuclear distance between the adjacent kernel is what? Metallic bond. Hope it is clear. Let me change the color of the pen first. Yeah, have a look here, guys. So it is clear that this is the metallic bond and these are the mobile electron with which, because here positive charge, and yes, here negative charge. So this is acting as an adhesive and holding these kernels quite strongly, which is actually called as metallic bond. Done. And therefore these are also called as metallic solid, guys. Now what happens, yes, what happens, these strength of metallic bond is decided by this mobile electron, guys. More the mobile electron, I'm repeating, more the mobile electron, more stronger the metallic bond. I'm once again repeating, more the mobile electron, more will be the strength of metallic bond. And yes, to the size of kernel, it relates as inversely. Size of kernel. So it is clear that bigger the size, lesser the metallic bond. Okay, and more the mobile electron, more the metallic bond. But as we are comparing only alkali metal, and we know that all of them have valence electron equal, and that is how much? Yes, one valence electron. So ye wala to compare karo hi mat when you are moving down and comparing this mobile metallic bond. So what we have to compare? Yes, we have to compare metallic bond with that of size of kernel only. Now, as you move down, what happens to size of kernel? Increases. Therefore, metallic bond has to decrease, guys. And this metallic bond is further going to decide the melting point. So more the metallic bond, more will be the melting point. Or you can directly relate the size to that of metallic bond here as you move down in alkali metal. More the size of kernel, less will be the metallic bond. So what will be the answer? Which alkali metal will have least melting point? The one which is having maximum size, and that is what, guys? Cesium. So cesium is having least melting point. मजा आया? Clear हुआ? Yeah, guys. I am going this. Many of my students says, ma'am, you make inorganic chemistry very, very explanatory, very interesting. लगता ही नहीं कि exception हो. I do believe these are not exception actually. They have a proper suggestion, proper explanation for those exception. For everything, the proper explanation, guys. And trust me, like physical and organic, inorganic is also very, very interesting. Very, very interesting. But you should you should study inorganic chemistry in this way only. Then you'll find it interesting, guys. Hope you really liked it. Let's go ahead. Now the next question, which of the following alkali metal give hydrated salt? Being smaller in size, lithium, yes, lithium can polarize the water molecule. And yes, the salt gets hydrated. For example, LiCl exists as this form, guys. Whereas these are bigger, so they do not do. Or you can say lithium is unlike in form, this particular form, that is it gives hydrated salt, whereas all other alkali metal do not give so. Lanka Bhedi, just recall it from the clue. Lanka Bhedi. Done. खूब गालियां दी ना लिथियम को अपन ने, कोई बात नहीं, वो बुरा नहीं मानता. Yes, guys. Now on the screen, which one of the alkaline earth metal carbonate is thermally most stable? I told you whenever you talk about thermal stability, guys, thermal stability of either alkali metal or alkaline earth metal, we will simply look electropositivity, guys. Okay, is this clear? So as you move down, you know the metal becomes more and more electropositive. If it is becoming more and more electropositive, more stronger the carbonate will be. So down the group, yes, down the group, more temperature will require to cause this, yes, to cause this decomposition. Okay, they undergo decomposition like this, guys. Similarly, this decomposes as CaO plus CO2. Strontium carbonate decomposes as SRO and CO2. And barium also decomposes at BaO and SCO2, guys. Is this clear? But as you move down, more and more temperature requires. Okay, and that is happening because down the group electropositive character keep on increasing, guys. So which one will be thermally, which of the alkaline earth carbonate will be thermally most stable? Tell me faster. Which one? Yes, the one which is at the lowest one, that is barium carbonate. Done, guys. So this is how we have completed S block element. Hope you guys must have learned a lot, guys. And yes, if you have liked the video, please share it. If you have not liked so far, इतना तो बनता है यार, So share it, like it, subscribe it. Okay, press the bell icon as well. And whenever you are going to take the subscription, remember you'll be getting 10% discount. So just apply this referral code of mine, which is very easy to remember, SA10, guys. Hope you'll be doing that. Thank you so much, guys. Bye bye for now.